This section is going to be full of lectures and assignments around persistent data. And first, we're going to discuss the problems of persistent data and how that even became a problem in the first place. So key concepts there that you need to understand are the idea of immutable infrastructure and the idea around containers being naturally ephemeral in design. So we'll cover those in the first lecture. And then we'll dive into data volumes and how those solve some of our problems around persistent data. And then we'll also dig into bind mounts and how that solves different problems with persistent data. And then we'll end up this section with a couple of assignments around how to preserve database data while replacing containers for databases, and then also around actually mounting code into a container from the host while you're editing it so that you can run that code inside the container live. And requirements for this first lecture are just understanding how to run containers and the container and image concepts we've discussed so far. Until now, you've only worried about what's needed to run a container, not the unique data that might be created once the container's running. Containers are meant to be immutable and ephemeral. Now, those are just fancy buzzwords for unchanging and temporary or disposable. But the idea here is that we can just throw away a container and create a new one from an image, right? So then we're not talking about an actual limitation of containers, but more of a design goal or a best practice. This is the idea of immutable infrastructure, where we don't change things once they're running. And if a config change needs to happen, or maybe the container version upgrade needs to happen, then we redeploy a whole new container. This gives us huge benefits in reliability and consistency and making changes reproducible, but there's a trade-off. So what about the unique data that your app will produce? Those databases or key value stores or anything else that your app spits out into a file. Ideally, the container shouldn't contain your unique data mixed in with the application binaries. This is known as separation of concerns, and Docker actually gives us a big benefit here. We can update our application by recreating a new container with an updated version of our app, and ideally, our unique data is still where it needs to be and was preserved for us while our container was recycled. Now, in case you haven't noticed so far, the containers that we've been using by default were persistent. So any changes in them actually were kept across restarts and reboots until we removed the container. Just because we stopped a container or restarted the host doesn't mean the container's file changes go away. It's only when we remove the container that its UFS layer goes away, but we want to be able to do that at will. So this problem of unique data is known in the industry as persistent data. And until containers, we didn't really have a name for that. Because, well, most things we built were persistent. Like, those old servers that have been running that old app for 5 or 10 years or longer. Everything was persistent by default. So now in the new world of containers and application autoscaling, persistent data creates a unique problem. So Docker has two solutions to this problem, known as data volumes and bind mounts. So Docker volumes are a configuration option for a container that creates a special location outside of that container's union file system to store unique data. This preserves it across container removals and allows us to attach it to whatever container we want. And the container just sees it like a local file path. Then there's bind mounts, which are simply us sharing or mounting a host directory or file into a container. And again, it'll just look like a local file path or a directory path to the container. It won't actually know that it's coming from the host.